This video will explain how to evaluate a piecewise defined function. First, we might want to answer the question, what is a piecewise function? A piecewise function is just what it sounds like, a function defined in pieces, and it looks something like this. The reason we need the pieces is because of what we want the graphs to look like. These are some examples of piecewise graphs, and you can see pretty clearly that those graphs have to be defined in pieces just because of the way they look. So how would we evaluate a piecewise function? We're going to find the correct domain for our function value and use that definition to solve. So here's an example of the definition of the function and the domain, and then the function values that we're asked to find. We're going to look at 3 examples. Here's my first example, and you can see the definitions for h of x and the domain values, and then underneath you see the function values we're asked to find. First, let's look at h of -2. So we need to look at our domain and see which of those domains fit for h is equal to -2, and it's the second one. So we're going to use that definition for h of x and plug in our value for -2. From there, we're just simplifying that expression, so we combine the -2 and the -1 to get a -3. A -3 squared is a +9, so our answer is a -9. Next, let's look at h of 0. Again, we need to look for 0 in the domain. And if I look, it's actually the same one, right? 0 is between 2 and -2. So I'm going to use that definition for h of x and replace the x with a 0. Now I'm just simplifying. So 0 minus 1 is -1, and -1 squared is a +1, so my answer is a -1. Lastly, we're going to look at h of 4. So we need to figure out which domain works for 4, and that's this last one here because 4 is bigger than or equal to 2. And for this, it says the definition of h of x there is just 1, so I didn't even have to do anything. Let's look at another example. Here we have a bunch of definitions there, 4 separate definitions, so 4 pieces of our graph. We also have then 4 separate sets of domains, and here is our list of function values we're finding. First, looking at f of -2, we need to find the domain where where x could be a -2, and that's this first one. So usually I would use that definition to replace, but the definition says if x is in this domain, then the function value is -2, so I don't have to plug anything in. Looking next at f of -0.75, I need to find the correct domain, which is the second one, because -0.75 is between 0 and -1, and it says there that the definition of the function for those domain values is that the function equals -1. So again, I don't even have any math to do. Lastly, for f of 1, again, we're looking for the domain where x is 1, and that's this last one. Notice it's not this one because here this says x is less than 1. It's this last one that includes the equal to. And again, this says the definition is that the function is equal to 1 for these domain values. So there we go. Once again, we didn't even have to do any math. Last example. Here's our 2 definitions and our domains, and then our function values. So looking for h of -5, first we have to figure out which of those domains works for -5. Well, that's when x doesn't equal -2, right? We only have 2 domains. when x doesn't equal -2, or when x does equal -2. So here x does not equal -2. So I will take that definition and replace the x with the -5 and then solve. -5 squared is 25, times 1/4 gives me 25 over 4. Now I need a common denominator, so that 4 turns into 16 over 4, and then I can do the subtraction, giving me 9 over 4. Next, we'll look at h of -2. That function value, that domain is when x equals -2, and the definition says that h is equal to 1 there. So we don't even have any math to do. Lastly, for h of 2, the domain would be when x doesn't equal -2. So I take the definition and replace the x with the function value of 2 and simplify. 2 squared is 4. Then I would have 4 over 4 minus 4, which is 1 minus 4, which is 3. I really hope you found this video helpful. Feel free to go back and watch it again. This is not a difficult topic, but sometimes it can be a little disconcerting because of all the definitions. Good luck!